My goal of this tutorial is to explain box plots in a way you will never forget. Box plots are very important, and if you are someone in the field of machine learning and artificial intelligence, I consider it a must for you to know a box plot. First of all, what is a box plot? So box plots helps you to visualize the distribution in your dataset. Okay, it provides you with a 5-number summary that will enable you to quickly understand your data from visualization point of view. Box plots will also help you to compare 2 or more datasets together. And finally, box plots will help you to spot outliers in your dataset. There are enormous advantages of box plots, so let's just go straight into it and start with an example. So first of all, I'll be using Seaborn to visualize my box plot. So I'll just import Seaborn. I've installed Seaborn already as SNS, and I'll import matplotlib as well. I don't think maybe I'll use it, but let me just run this. And over here, I'll start with the dummy data. So I'll call it this data, and this data will be a list of some numbers. So I will just miss some numbers. Alright guys, so let's start with these numbers, and I'll just go ahead and create a box plot using the Seaborn library. So I can just do sns.boxplot, and over here I can also specify my orientation. So orientation, I want it to be horizontal. Okay, so I'll write plt.show here, and I'll quickly run this. So this is how a box plot look like. Okay, this is how a typical box plot look like. And when I was defining what a box plot is, I told you it provides you with a 5-number summary. So these are the 5-number summary we are talking about. This right here, this line right here is the minimum. The second line right here is the first quartile, and then this middle line right here is the median, so making 3, and the fourth one here is the upper quartile, and the last line right here is the maximum. So what I would do here is to pull up the paint application and draw the exact same thing so that you can see better. So a box plot looks like this, where we have the maximum here, we have the minimum here. So I'll start, this is the minimum, this is the Q1, we call it Q1, or the first quartile. Then we have the median of the entire data set, and we have the third quartile, or Q3, and finally we have the maximum. Okay, so in this particular data set, what this box plot is trying to tell us is that the minimum number we have here, okay, the least number we have here is 1. So you can see the minimum here, right, is on 1. So it tells you the minimum data point in your data set is 1. Okay, let's look at the maximum. The maximum, which is this last one, which is this one, is 5. So it's telling us in this data set that we are having, the maximum number is 5. Is that right? Okay, so I think this is self-explanatory and it's easy to spot. Then the next thing we'll talk about is our Q1, okay, which is also known as the first quartile. So the first quartile here is telling you that, okay, in this data set that you have, okay, 25% of your data fall behind this data set. Okay, so 25% of our data set looks like it's having 1, 1.5, all the way up to 2. So 25% of our data set have these particular numbers, the numbers behind it. Is that okay? From 1 to 2. So 25% of your data set is between 1 to 2. Then when we come to the median, this is the median, or the middle number of our entire data set. So the middle number of our entire data set is 3, and this is what is trying to communicate. So you can see straight up, just by looking at this particular data set, our middle number is what? 3. When we rearrange this, which we'll do in a sec, it's telling us that the middle number in our entire data set is 3. Then we go to the Q3, or the third quartile. What the third quartile is trying to tell you is that about 75% of your data set, okay, is between 1 to let's see, 3.7, somewhere here. Okay, so that's what the third quartile is trying to communicate. So then finally we go to the maximum number, which tells you the maximum number in your data set, okay, the max number in your data set. So when we look at this data set, the max number here is 5. Okay, so this is how the box plot is trying to communicate this particular information to us. And from this box plot, we can also find what we call the range of our data set. So the range is the maximum number minus the minimum number. So when we subtract the minimum number from our data set from the maximum number of our data set, we are going to get a range. So in this case, our maximum number is 5 and our minimum number is 1. So when we subtract 1 from 5, we are going to get 4, and this is what the range is. So the range is telling us the range of our data set. Okay, it gives us the range for our data set, and that's how you can find the range. So you can also find the interquartile range, which we call simply IQR, and it's very simple. All you need to do is to subtract the first quartile from the third quartile. So this is the first quartile, right? The first quartile, and this right here is the third quartile. So if you do, let's say Q3 minus Q1, this is going to give you the interquartile range, and that's where 50% of your data set is spread across. So you can see by just having a box plot, you know a lot of information about your data set. In my intro, I also made mention that box plots will help you to spot outliers. So in this data set, let me say I want to add a data point which is very far from the rest of the data. So I'll quickly add something like 10 here. All right, so in our data we are having number distributed data points, but all of a sudden I added 10 here, and let's run this and you see how the box plot reflect this. So over here now you see our box plot, you see how all the data points are looking here, and all of a sudden we have a box here, we have a circle here, sorry. So this circle here is telling us that okay, we have a data point which is 10 right here, and this 10 here is an outlier. It's far from the rest of the data point. So easily when you have a box plot and you have these circles as some part of it, is telling you or is communicating to you that you have some outliers in your data set. We can also have negative outliers as well. So if I should add a negative number, for instance maybe negative 10 as well, uh, that should be able to also reflect in our data set. So now you can see we also have another circle here which shows that okay, those data points are far from the other data we have. So it's not our data point now is not well distributed. We have some outliers in our data set, and if you have outliers in your data set, this will give you this information and you know how to process this data set before building a model with it. So guys, this is all I have to teach you about box plot. Let me know what you think about it, and also if you find this great, let me know in the comment section so that I can make more tutorials on visualizations and how you can interpret them when you are building your data science projects. So thanks for watching, and I will see you in the next tutorial.